to welcome Professor John Roberts from the University of New South Wales in Sydney, Australia, to the monthly colloquium of our graduate school. But actually, Professor Roberts is here for for 3 months, I must say, as a visiting professor. And unfortunately, your visit is nearing its end. Sadly enough. But I think it's a time we'll spend, at least for us, because we learned a lot from your lectures and from our discussions. Not only to do with mathematics, because as I understand, you started off basically studying 2 fields, physics as well as mathematics. And
yes.
How did that come about? Where did that interest come from?
Well, firstly, Ralph, let me thank you very much for hosting the visit and for the school. It's been a wonderful experience, and I hope it brings tighter links. I've very much enjoyed the discussions. I'm a sort of perhaps an accidental mathematician because at school I was perhaps more interested in physics and chemistry. I like mathematics, but there were lots of things I was interested in. And I actually enrolled to become a doctor at the end of end of school. And then I thought, oh no, maybe I want to do physics. So I took a year off and made some money, and eventually decided, oh, I want to do physics. And so I went to uni to do physics, chemistry, and maths. And then as time went on, I realized to be a very good physicist, you should have good intuition.
Yes.
Also, I got to say, the experiments were driving me a bit nuts, and the equipment breaking down. And I became more enthralled by particular areas of maths, and I thought, oh, these are very beautiful ideas. And I remember being very excited by a couple of key ideas, even at school. The first time I saw calculus, I just was in shock, and I thought, this is such a beautiful idea. So there was all these sort of signs that mathematics was very appealing, and it gave perhaps more rigor than physics would. And so eventually I turned more to mathematics, but I could have gone physics or maths up to the end of 4th year.
I see.
But yeah, no, I'm very happy with what I did, so yes.
And well, being interested in many different things makes university either a very interesting experience, because you can go and sneak in probably into other lectures and pick up some bits of information.
Philosophy lectures, for instance.
Okay, so how was that?
That was very interesting. I had friends doing philosophy, and I crashed a few lectures. One was, what is happiness? I remember that very distinctly. But at the end of the lecture, I still had no idea what happiness was. And I thought I'll pursue it in other areas. Yeah, no, I think it's good to be interested in many different things, and in mathematics and elsewhere. I think because then you see patterns and you see similarities.
Yes, exactly.
And I think that's very helpful.
I understand that after your PhD you spent some time abroad.
Yes, in Amsterdam.
We'll come back to that point later, but was that very common in those days? Because you went to a very special place, in a sense.
Overseas?
You went overseas, you went to Amsterdam.
Yes.
Was that because of a specific choice of topic? Because there was this very strong group around Hans Capel.
Yes.
Basically pioneers in discrete integrability.
Exactly. And I in my 4th year of undergraduate, I discovered really dynamical systems and statistical mechanics. And I thought both of them were wonderful. And the ANU is one of those national universities that has a teaching faculty, but also has a research faculty. So in the 4th year, we were able to have lectures by quite esteemed researchers who gave guest courses.
Yes.
So I had one by Rodney Baxter, who many people in Japan would know in mathematical physics, and also by Andrew Koppel on one-dimensional dynamics. So that sort of sealed the deal that I wanted something in stat mech or dynamical systems, and basically everybody studying chaos theory, a lot of them had come from stat mech. And so I had the good fortune, probably at the end of my first year of my PhD, to meet Reinhard Quispel, who'd just come as a postdoc with Rodney Baxter. And we started working, even though he wasn't technically my supervisor, because I was in Melbourne, we started working together, and of course that introduced me to the whole school of Hans Capel. And so it seemed a natural thing then to go, and of course Hans was a fantastic fellow and fantastic mind, and so I feel very fortunate to have been there at what I realize now is a very seminal time, because this was in 1990.
Yes.
It's my first year. This is when they wrote the first paper with Frank Nijhoff and Vasilis Papageorgiou.
Yes.
They wrote the first paper about reductions from lattice models and showing complete integrability. So, very exciting times.
Coming back to what you mentioned about ANU, so Australian National University. So you did your PhD at Melbourne.
Yes.
Was it encouraged to actually go to other universities to take courses, or?
No, and in fact, I think I like moving around, and I think life is very beneficial from doing so. So I deliberately went somewhere else. I thought about going overseas for my PhD, but instead I went to Melbourne. And I don't think there is enough mobility actually in Australia of either students or academics. At that time, I think things have changed, but yeah. At that time it was perhaps a little bit unusual.
So you ended up going abroad for a postdoc, and again, given the times in which we live, that might become difficult already in the near future. But talking about myself, doing a postdoc abroad is of immense importance if you want to become a researcher. And what are your feelings about it?
I think it's absolutely essential, because, coming back later on when you're on hiring committees, in Australia there's a little bit of a culture, and certainly there was there, that if you're in pure maths, you went overseas for your PhD, often to America. In applied maths or theoretical physics type, mathematical physics, you often did your PhD in Australia, but it's absolutely essential to be part of an international pursuit and to build up networks. And to me, one of the great attractions of academia is its international flavour. I like that very much, and I hope to goodness that people are not going to be deprived of that.
Yes. But it's interesting to hear that or maybe the impulse to go abroad depended on fields. In my experience, basically there was, well, I come from a tiny country, so it was sort of natural that people would go abroad, but there was a very big push for everybody pursuing a research career to spend at least 1 or 2 years abroad. So that was not the case at that time in Australia.
Oh, I think it was the case certainly at the postdoc level. So I think it had to happen at some level, you either for your PhD, and I think the reason, if you like, people more pure maths inclined went often to America was because of the graduate courses and to get more knowledge. See, Australia doesn't have graduate courses as an official part of the PhD program.
I see.
And that's, which is probably not great, and that has been sort of addressed in various ways. But the idea also, Australia's far away from lots of places, so you have to get used to the idea of getting your mileage hours up, but also to me, as I said, to be part of an international community is just so important. And some of my happiest memories of academia are around a dinner table in some other country where you're talking to people from all different countries and you're exchanging views on science and everything else. Yeah, it's good for everyone, hopefully, yeah, good for the world community.
I think dinners are important in that.
Dinners, vote one dinner.
So any other good advice to students or starting researchers, except joining dinners as much as they can?
I think embrace abstraction, actually. I think when you're young, or at least in my case, sometimes when I saw abstract mathematics, I thought, wow, you know, why is this being done? This seems just so, how is this going to help? But I think that's a question of not understanding that as maths as a field matures, or any field matures, someone can often look down with the bird's eye view and see the same idea in different quarters. And I think the other thing I would say is don't pigeonhole your mathematics. So I've already talked about this culture sometimes where there's applied mathematics, pure mathematics. Except for sometimes administrative reasons, I don't like this division, and I think modern mathematics is all the better for taking a cross-pollination of ideas and methods from everywhere. So I would say be very open to reading, absorbing, going to seminars in different topics, so that you can add to your toolbox and you can meet more people. And also it helps collaborating. So for me, some of the joys of academia are its internationalization and collaboration, which often lead to lifelong friendships and bonds, intellectual and otherwise. And I think that's a fantastic gift. Yeah.
I agree that you should broaden your mathematical horizons as much as possible, especially in our field, because if you're studying integrable systems, which are, it's a question people often ask me, how do you define integrability? And
yes.
Already that is a question without a good answer, because
exactly.
you draw on different concepts from different fields.
Exactly.
Especially for us, it's very important to have
absolutely. And
horizon.
I think that is one of the big attractions to me of dynamical systems and integrable dynamical systems. They're sort of like umbrellas that give you a bit of free range to go all over the place looking for ideas, and they pop up, as you know, in all sorts of different areas. And to have that freedom is exactly in line with what I said before of being open to cross-pollination. I looked up this morning whether Japan has bowerbirds. Apparently it doesn't. But for people who don't know, a bowerbird is a type of bird, and the male, to make himself attractive to the female, goes around collecting different things, often they're blue, I think, and puts them in the nest. And I sometimes think it's good to be a mathematical bowerbird and to be open and go around and collect things, because you'll see some beautiful ideas and they may morph into something of benefit, but if not, they increase your knowledge. Yeah. So I'd say be open to cross-pollination, and also be open to just free-range thinking. I really like that idea. It was used in music and art. We're another creative pursuit, which is a form of composition, but we use ideas, and we need to obey the rules of logic, but there's still an aesthetic we're aiming for. And I think the more tools you can bring to the composition, the better off you are.
I fully agree. I think
I think you're like-minded. I'm very glad to see and hear and know now. I knew it already, but yeah.
Thank you very much. I think the colloquium is waiting, so I think...
No, it's an absolute pleasure, and thanks very much,
Thank
Ralph,
you very
for
much
everything.
for the interview. Thank you very much.